Hello and welcome back. This is the final project. So I am choosing option 3, the math story and reflection. So a little backstory to my project. In my public speaking class earlier this semester, I did a speech about how Dungeons and Dragons, or D&D, can be quite educational in the classroom. And my aha moment was, maybe I could build a lesson plan with D&D inspired math dungeon kind of deal. I love Dungeons and Dragons. I play every week with a group of friends. So, you wanted this project to be us. Well, this is definitely me. So, I'm gonna kind of give you a quick rundown of the dungeon I made, but I have a feeling you're not quite attuned to the lingo and stuff for D&D. So, I made a little backstory to the dungeon before the class starts. So, long ago, the wizard Fractitio trapped a kingdom's treasure in a dragon guarded by math monsters. Only true math knights, armed with fraction spells and division swords, can free it. Will your class unlock the vault? So, little basics of, character creation, so that way students can really, get into it. So, they can create a character, they can be a human, elf, even a cat, It's up to the student. I did simplify it so that way students can understand it a little easier. Dungeons and Dragons has a lot of stuff to keep track of, and I didn't want to overwhelm them, so this is a very simplified version. So the only abilities they'll have, Sword Strike, which is just solving it by themselves. You get +3 damage to the monster, aka the math problem. Spellcast is just, call in a friend to help. I need a lifeline kind of deal. And that deals more damage because, you work in pairs, you get more out of it. Shield block, it's to explain your reasoning. So if a monster tries to quote-unquote attack, you can parry it by explaining a mistake. So, if the monster isn't correct, you can parry their attack, blah blah blah, that kind of thing. So, each student starts with 15 health points. Every wrong answer deducts 2 HP. And so every correct answer gets a token, and 10 tokens would get the class extra recess or whatever reward you think they'd like. And I have a small abridged version of what the little challenges are, but I think it'll be easier to show you. Just giving you the rundown before we get into it. So, we will start at the door. The door! Sorry, that's a Charlie the Unicorn reference for all of you old millennials out there. Alright, let's get into the backstory. Long ago, the wizard Fractitio trapped the kingdom's treasure in a dungeon guarded by math monsters. Only true knights, armed with fraction spells and division swords, can free it. Will your class unlock the vault? This is the door that you have to unlock for the dungeon. So, the problem to unlock the door to start the dungeon, which is basically just a warm up, we're gonna do something a little simplistic just because it's a warm up. So we're gonna do, hold on, I have to get my pencil. There we go. There. 1/2 times 4. Okay. And this is going to be an algorithm-based solving. So, I'm going to ask the students to roll their d20, which, if you're not familiar, a d20, hold on, looks like this. So, you'll have them roll, and if it's between 10 and 11, group A will go. If it's between 12 and 20, group B will go. So I have them kind of separated like that, but that's a d20. We'll go back to our little door over here. Okay, but this is going to be an algorithm problem. So if I roll the d20 and let's say an 8 comes up, group A goes. So we'll have somebody from group A volunteer to do this, and you'll just have them use one of their abilities, whether it's the attack or calling in a lifeline or identifying any issues with it before solving. Just depends on how the students want to do it. But it's a little, I think this will be fun. So 1 times 1, just do the butterfly method is what I like to call it. So 2 times 4, that's 8, right? So let's see, multiply the numerator by the whole number. See, now what I'm doing is wrong, and I'm doing this wrong on purpose so that way they can use their other ability, which is, let's see, their ability is to do a shield block, right? So if they do a shield block because I'm doing the wrong method, that adds minus 2 HP. That's just an example. Okay? So we're gonna try and solve this the correct way now that I've given you a thing. Now, I'm also, oh, hold on, sorry, spaced right here. Okay. So that was just an example of what the shield block would do. Since I did it wrong, they can identify it and go for it. Alright, now, we're just gonna do this. 1 times 4 is what? 4, right? And 2 times 1 is 2. 4 over 2. And we're gonna treat this like a division. So 4 divided by 2 equals 2. And that's just the warm-up for getting into the dungeon, which I will show you now that we've solved the problem to enter. So let's find that. It's right here. Okay. Oops, save this. Okay. Now this is the dungeon. Just open the door so they can choose to go left or right. The dungeons in each room are about the same, so that way, you know, whatever they choose, they still have a problem. But as the campaign, mini-campaign goes, they'll just travel through the dungeon, and the vault back here is what they need to do, get to finish their quest. Okay, so let's go to the Goblin's Den, which is our first actual problem. Let me just pull up some stuff. There's a lot to keep track of for D&D, but it's pretty nice to do. Alright, so Goblin Den. This room is full of a bunch of creepy little goblins. And what they're doing is trying to prevent you from going farther. You need to defeat them to progress through the dungeon. And we are going to multiply fractions with models and area diagrams. So, hold on, let me just get some pen and paper out so that way I can do this. Okay. Well, sorry about the wait. Okay, so we are multiplying 2/3 by 3/4. And we are starting off with multiplying, but we'll get into fraction division. Okay? So, this is the problem the students are going to have to do to defeat the little horde of goblins we have in this little room over here. So, we're going to swap over to our grid paper just so that way we can get this going. Need to save that, sorry. And that is the grid paper from last time, so let me just get a regular grid paper going. Sorry. There we go, that's better. Okay. So, we're gonna write down the problem again on this page. 2/3 times 3/4. And I promise this will be a lot more fun in a setting with more people playing. I really wanted to challenge myself to make a fun and engaging lesson plan, so that's kind of the whole point of this. So, we are going to draw a rectangle to represent the whole of what would be the answer of this. So, I'm gonna change my color here so that way it's gonna be way easier to see. So we are gonna draw a nice rectangle. Doesn't have to be perfect, obviously. Just has to be a legible rectangle. You can see where it starts, where it ends, and you can divide it into equal parts. So we are gonna divide the rectangle into 3 equal vertical parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's going to be about 4 squares in each part and I'm kind of zigzagging my lines so that way it's a little more legible. So that's one section. Section 2 and 3 done vertically. Okay? So, we have our rectangle and 3 vertical sections to represent the 3 for the thirds. Now, we are going to shade the 2/3. So, we just color it in. Doesn't have to be perfect. None of us are Picassos. Well, I'm sure there's some are out there, but I'm not a Picasso. So, this is 2/3 of our rectangle colored in. Very poorly, but it is colored in. Okay? Now, we are going to get the second part of the rectangle colored in. I'm going to use red for this, so you can see the difference, because blue is a little hard to ledge and see on this. So we are going to divide into 4 equal horizontal parts. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so about 2 squares each. There's 1. There's 2. And it doesn't have to be perfect. You can just, see the separation. Okay, so there's 1, 2, 3, 4 spaces in there. And we will shade 3 out of these 4. So And I love area models just because it gives it so much visual to it. So, got the first two, now we're gonna go down to 3. Okay. Okay. So, we will have them find the overlapping area to represent the product of these two fractions. In this case, out of the total 12 parts, 3 vertical, 4 horizontal, 6 parts of these are overlapping by, 6 of these are shaded by both the blue and the red. So we are going to calculate 6/12, which we know can be simplified to half, but we'll get to that later. There we go. And which simplifies to 1/2. Okay. And using the area diagram effectively visualizes the multiplication process. It shows the partitioning of the whole into equal parts based on each fraction's denominator and identifying the overlapping shaded area. This method definitely confirms that 2/3 times 3/4 equals 1/2 just by doing the visuals. So we'll go back to these goblins on the page. Hold on. I'm not going to save that. Okay. So, that is 1/2. Ah! You students are too smart! You have defeated us! Ah! There's gonna be some role playing, make it fun for the students. So, sorry about that. But, yeah, we will go on to our next little layer in here. We are gonna do a puzzle bridge. So, hold on. We are gonna be doing a new page for this. Okay, so using number lines, we will divide 5 by 1/3. Okay. And give me a moment to get my supplies and bearings for this going. Just give me 1 second. Oopsie daisies. Okay, hold on. And the whole point of this is just to get students engaged and have fun. Something I've been having problems doing throughout the semester. I just wanted it to be a fun little thing. So let me just get a number line going. If I can find one. Goodness. That is one material I did not prepare. I am so sorry about that. I thought I had already prepared this, but I guess it'll show you a little bit of my process on how I do my lesson plans. So, edit, paste a picture. Okay, have our visual now. So let me make this bigger. Boop, 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 boop. Okay. Now, in this dungeon, there's a rickety, crashing bridge. There's only enough room to go in one by one, single file. It's a really rickety bridge, and in order to get across the bridge, they have to solve this. So, to divide 5 by 1/3 using a number line, we need to consider how many segments of 1/3 can fit into 5, right? Since 1/3 fits into 1 exactly 3 times, we need to multiply that by 5. So that would be 5 times 3, which would be 15 jumps. This means we can often divide the number line from 0 to 5 into 15 equal parts, each representing 1/3. So, let me switch to my pen. So, let's get a nice color going. There's 1, 2, 3 parts. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So you just have them count each little jump. So there's 1/3, 2/3, 3/3. That's 1. So just have them write down how many jumps they did to get to the 1 number. 1 jump, 2 jump, 3 jumps. That's another 3. 1 jump, 2 jump, 3 jumps. Add another 3. 1 jump, 2 jump, 3 jumps. Add another 3. 1 jump, 2 jump, 3 jumps. Add another 3. Now, you can have your students just add them up, or you can have them rewrite it as a multiplication fact. Either way is fine, but that would equal 15. Because there are 1, 2, 3, 4, 5. 3 times 5 is 15. So I'll also just write it down here. That way the students can really just grasp it, like, whoa, yeah, we did that. I'm so sorry. That was supposed to be 3 times 5, not 15. Oopsie daisies. There we go. 3 times 5 equals 15. Now, the class has traveled through the bridge. Although rickety, some people have dropped maybe a few items down the abyss that the bridge covers. We still made it safely. We made it soundly. And as we go through the dungeon, you hear a little roar. Roar. What could that be? Well, we have to progress through the dungeon to figure that out. And we go to, let's see, we go to the end. Sorry, I had to save that really quick. This guy, he is the big baddie. And the big baddie has a mixed number multiplication and division. So this is a 2-parter. That's why he's the end monster. And this is probably where the class is gonna have to do their I need a lifeline spell, or collaborate, or try to use their shield activity where they try and point flaws out. Just depends on the group. So let's roll our d20, and let's say I rolled a 15. So group B goes first on this, right? Okay. I am so sorry about this. Okay. So. Roll. How dare you go into my house and steal my things? This vault will not be entered. The only way you can get in there is to go through me. Ho 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 ho. Oh, ho, ho, ho. I don't really do well with evil laughs, so just pretend I did a really good evil laugh, because this is the big baddie. Because there are 2 problems we need to solve. and they can choose to either do a algorithm, they can choose to do a visual model. This one is entirely up to them because it does have a few components, but we are doing 1 1/2. Alright, and we are multiplying it by 2/5. So we have a mixed number multiplication problem here. Okay. Alrighty. Oops. Alright, so we need to calculate the product of 1 1/2 multiplied by 2/5. And we can convert this into an improper fraction for our step 1, the whole mixed number. So 1 1/2 would be 3/2, because 2 out of 2 is 1. You add the extra 1 and you get the 3. And then we just bring down the 2/5 over here. Okay. Alrighty. So we will do 3 times 2, which is 6. And if you haven't noticed, my handwriting in this has gotten a lot better throughout the last few lessons. Quite proud of myself on that. Thank you very much. Okay, so 6/10. We can simplify that because 6 and 10 can be divided by 2. So 6 divided by 2 is 3. And 10 divided by 2 is 5. 3/5. That is the sum for the mixed multiplication, mixed number multiplication. 3/5 is our magic number. But that only takes away half of this guy's HP because there are 2 problems. So, a mighty blow. But I'm not done yet. You guys are gonna have to do better than that to get to me. So, we will start this over. I have another. So, we are multiplying 1 1/2. Oh. Okay. So, hold on. Actually, we are going to do a division problem. Sorry, I got a little caught up in this. So, we will do 6 divided by 1/4. Okay. And you farewell travelers have no idea what you can do, what you're capable of. Only the worthy will get to the vault. So, as the students get through, maybe roleplay with the big baddie for a little bit, we will have them probably roll to see who can deal the final blow. So, if there's a classroom of 20 students, I'm going to roll a d20. So, if student number 17 gets called up because I rolled a 17, then so be it. Student number 17 will definitely have to try on this. So, to divide 6 by 1/4, we need to multiply 6 by the reciprocal of 1/4, which is 4. But we need to get this a little bit. And again, we can have the students do whatever. It can be an algorithm, it can be a a visual problem like base 10 blocks. It can be a number line. Totally up to them. Okay, so I like to rewrite them like this, so that way top is on top, bottom is on bottom. Okay, so and this is where the butterfly method happens. Okay, so 6 divided by 1/4, I'm sorry, 6 times 4 is 24. Butterfly method is for division. Okay, and 1 times 1 is 1. So that will just be there. And therefore, 6 divided by 1/4 is 24. Which is kind of weird, don't you think? The reciprocal, when you think of division, you think you're going to end up with a smaller number, but that's not always the case when it comes to fractions. Anything can really happen, just like in a game of D&D. So, a common mistake I would probably address in the class while they do this is, don't forget to take the reciprocal of the divisor. I almost just forgot about that too, so that's why I'm mentioning it. And also, incorrectly multiplying without inverting the fraction can be another common mistake. So, just want to make sure you're getting that to him just right. But let's just say student number 17 dealt the final blow by solving this, giving us the magic number of 24. I have been defeated. Although you guys are strong, my knowledge is stronger. Oh, really? There's one more problem they need to do. They thought they did the final blow, but they didn't. Dun dun dun! Second wave. Okay. Now, this one is more like a riddle, I would say. If a dragon holds 5/8 of his treasure and steals 1/4 more, what's the total? And you can see the big bad here isn't in good shape. He's on its last legs. You thought that the 2 problems were all you needed to beat him, and guess what? Nope. Okay? So, we're gonna have student number 17 just kind of get one of his buddies, and we will have both of them work together. So it's gonna be an extra +3 damage for the attacks and stuff. Again, it's a little bit to keep track of, but I promise it'll be really fun. So, let's see. Oh, you are no match for my mathematical abilities. I am the Mathemator. Dun, dun, dun. Okay. So, let's see. Dragon has a total of 7/8. That will be the answer, but the students don't know that, so we are going to convert 1/4 into 8ths, because that's the easiest. So 4 times 2 is 8, and 1 times 2 is 2. So we will rewrite 1/4 as 2/8. And I did give him a little bit of an easy one for the quote-unquote killing blow, just so that way they can get through it and go, yeah, yeah, You know how kids are. So, 5 plus 2 is 7. And the denominator stays the same. So, 7/8. That is the killing blow. Ah! I have been defeated! You are a true math warrior. And I will give you my treasure as a reward. And we get to a nice little treasure box here. Oop. Yep, a little treasure box. And so the students get to the vault, get the treasure, and, you know, if they completed all of their dungeon in one go, that is extra recess time. Little bit of a reflection. I really wanted to make this a fun, not so much of a cookie cutter kind of math plan. I had some problems throughout the semester trying to make it engaging and not so boring. With math, it's kind of hard, but I really did try, you know. And I'm sure in an actual classroom setting, this would probably be really fun and engaging. It's not as, well, I would say, you don't have to keep as track on a lot of things as you do in a regular D&D game. So this also kind of gives them an opportunity to keep track of multiple things at once while also taking care of their math problems. So you have to have a lot of number sense to play the game. Statistics is involved, and honestly, you can really do anything in a D&D campaign. So that is the end of this small mini campaign. Little rundown, go through a few of the problems, and the reward for the class would probably be extra recess time or something fun for all of them. I actually did have a lot of fun writing this out as a lesson plan, so thank you. Really, this semester has challenged me in a lot of ways, and I wanted to challenge myself too at the end. And I think I did pretty well with this, but you're the judge of that since you're the almighty professor. So, I leave this in your court. So, thank you for your time, Professor Jody, and thank you for a wonderful semester. It was pretty fun doing all of this. So, bye!